This is problem 97 of Neetcode 150, Alien Dictionary. This is a hard problem. So we are given a foreign language which uses a Latin alphabet. So we're gonna have all the letters of the alphabet that we know, at least in English. But the order in which they appears in their alphabet is not the same as ours. So we're gonna receive a list of non-empty strings words, and we know that they are sorted lexicographically based on the rule of this new language. We have to derive basically the order of the alphabet in this language. It is possible that the order is not valid, in which case we're going to have to return an empty string. Okay, so all right, so let's just go see an example. That is a pretty obvious one because we're just giving um, one character per entry. So we have a Z that appears before the O. So basically the order is ZO. But let's see another example here that might be a bit less obvious. So in this example, we have R, H, R, and N, and then we have H, R, and F. So basically what we're gonna have to do is that we're gonna have to put them side by side and check which letters is different. So initially we have a H on this one, and we have a H on the right side as well. Then on the left side we have R, sorry, as the second entry, and we have an R as the second entry for this one as well. And then we have an N as the third entry and F. So the fact that the N is and F are the first two characters that are not the same means that the N, which is the first one, right, is the one to the left, N comes before the F, and this is exactly what they're telling us here. We know that N comes before the F. Now, if we check these two here, okay, they're not of the same length. Great. First, we have an H, and then we have an E. So right away, we have two characters that are not the same. So we know that from this, the H is going to come before the E. This is a pretty good logic. Then we have ER and we have E and N. We know that both starts with an E, so it's fine. But then we have an R and we have an N. So we know that R is going to come before the N. And this is the exact same logic for the last one. We know that the E here is not the same as the first R, so we know that the E is going to come before the R. And this is, if we assemble all of that, we're going to have H, E, R, and N, F. Okay, so that's it. Just in edge case, if we have, for example, the first word ABC, and we have another word AB, that will be incorrect. So we will have at this point to return an empty string like that, because both first two letters are the same, but then the C is well, the C can come before nothing, right? So this is, in this case, we're gonna have to handle from the beginning. So let's go ahead and actually code this. But before we code this, I just want to speak about the technique that I'm going to use to solve this problem. So what I will do is that I will create first a dictionary in which every single character. So for example, if we go back to this example, I will have a dictionary with the H, I will have a dictionary with the R, and like all the letters are all the different and distinct letters will become a key, and their values will be all the letters that comes after it. Right, so that once we add, let's say, the H, I know that in my dictionary, at the key of H, its value are going to be E, R, N, and F. So what I will do once I add the H, I can basically go add the D. Well, I can go search the other one. And my logic will be that I will also keep track of how many letters comes before the one that we have. So let's when we start at H, we're gonna see that 0 letters comes before H. So this is when we are gonna add this letter in. And then once we add H, we're gonna go see all the values that comes after H, and we're gonna decrement this count by 1. So at this point, the E, which used to have one letter, right, the H before its appearance, is gonna have a value of 0. So it's gonna then be added. So that's the logic we're gonna use. We're gonna go for every letter for every word. So we're gonna have a space complexity and a time complexity exactly as they are suggesting. So all plus, well, big O of n plus v plus e, right? So here v is going to be basically the number of unique character that we have. E is going to be the number of edges, and n is going to be the sum of the length of all the strings. So let's go ahead and code this. You'll see it is not so bad once we get into the code. So the first thing we want to create is basically a dictionary. And inside my dictionary, what I want to have is basically, I want to have every single characters, and I want to have the set of all the values that comes after these characters, check like this. And I want to have this for every word. So for W in words, and also for C in W. So basically, it might seem complex, but for all the W in the words, because words contains many words. So for every single word and for every single character in that word, basically create this. So the key is going to be the character, and it's going to contain initially an empty set. Now I want to create another variable. I will call it in degree, and in degree is going to be also a dictionary. And initially, every single character is going to have a value of 0, and the number that is attached to that character is basically the number of letters that comes in the alphabet before that particular letter. So I want to have this basically for all for the C's in ADG that we created earlier. All right, so that's good enough to start. What I want to do now is that I want to go basically for for every single word. So what I will do is that I will first say for I in the range of the length of the words -1. So we're gonna go see every single word, and we want to compare these words with the next one, right? Exactly like we did in the example. So for I in the range of the length of the word -1, let me just create the word 1 and the word 2. Word 1 is going to be equal to the words at the index I, and the word 2 is going to be equal to the words at the index I plus 1. Right, just like this. Cool. Now I want to keep track of which word is the smallest one, because this is important. Remember the example with ABC and AB, right? We want to ensure that we are going to take care of this edge cases. So to do so, I will keep track of the min length variable, which is basically the minimum value between the length of the first word and the length of the second word. All right. So now how are we going to check if basically we have an edge case like A, B, C, and A, B? We're just going to check if the first word is greater than the second word, right? Because recall that in our example, ABC, which is the first word, is greater than our second word, AB. So this is the first check. We want to check if the length of W1 is greater than the length of W2. And also the second thing is that basically W1, if we just take the first characters, like for example AB from ABC, well, these are going to be equal to the entire string of W2, so it will be equal to exactly this. All right, so this is the case where we want to return an empty string. A lot of blah blah just to handle an edge case, but now let's actually get into the interesting part. So we will go for every single characters in both strings that we have. So we're going to do so by saying for G in the range of the min length. And what I will do is that I will check if both characters are not the same. If they are not the same, well, this is where our business starts. So let's go ahead and write if W1 at the index G is not equal to W2 at that same index. So if this is true, well, I will be willing to add in a dictionary W2 to W1, because remember this here, the ADG is holding basically all the characters, and for each characters, the values it has are basically the characters that will comes after it. So what I will do is that I want to check because it is possible that we've already encountered this, so we don't want to add it twice. So if w2 at the index g is not in the ADG for that particular character. So if this is the case, I will be willing um, to add this word. So w1g that add w2g, just like this. All right. So now we know that if both characters are not equal, the first character, well, the character of the first words will obviously comes before the character of the second word at this index. So in the ADG, which holds all the characters and the characters that comes after these characters, I will add this W2 to the W1. All right. And after this, what I want to do, and degree at that particular that character, so at W2, um, I will increment this by one because I know that there is one character that comes before the character of W2. So let me just write this maybe in an easier manner. So let's say I have href and rt. So basically I will go for every single character, and notice that the min length here is going to be 3 because both are exactly of the same length, right? So we have 3 characters here, we have another 2 characters here. So what I will do is that I will go for g in the range of 3, and if the g, if w1, which is href, is not equal to w2 at this index, then we actually we do this. Okay. So initially at uh, g equals 0, first index, h on both sides, nothing to do. Then at g is equal to 1, we're gonna have r and r, nothing to do. And then we have f and we have t. So this is not equal, so we're gonna go see here. And then inside ADG, we're gonna have something that looks like f, and now we have a set, and inside this set I will be willing to add this t, like that, because we know that the t will comes after the f, right? And then in degree, right, um, at the at the key of t, I will basically increment it by 1 because now we know that there is one character, which is f, that comes before this. Okay, so I hope this make it a little bit clearer. Um, Once we actually find a word that is not equal, we are good to break the loop. So I'll break it here. And now this is where we want to use a DQ. And look at this. I will create a DQ and I will put all the words whose integer values is 0, meaning that no words comes before it. And technically there should always be one word at a time. Otherwise there is an error earlier in our code, but it should not happen. So I'll create a queue, which is going to be equal to a DQ. And initially in our DQ, I will have C, all the characters for C in degree. If and degree at this key is equal to 0. All right, so meaning that there's no words that comes before this one. So I will also create an output here, initially equal to let's just say a string. It's gonna be easier. And now while there is a queue, I want to do the following. So what I will want to do is I will first be willing to pop from the left of the DQ the character. There shall only be one at the time. All right, so now we know that we have the words that we have to add. So I will say output plus equal that characters. Right, and now for all the other words, I will say for other in ADG at this C. So now we know that ADG is holding all the characters that comes after this. So for all these others, what I want to do is that their n degree value will be decremented by 1. And then we want to see if by decrementing it by 1, we made it equal to 0. So if n degree at this other is equal to 0. Well, we know that this is a word that is going to be added inside our alphabet. So we're going to say q append, and we're going to append this other. So with that being said, the length of the output should be equal to the length of the integrity because the integrity is holding all the different characters. So once we break the loop, we just want to handle this edge case. So in the case where basically the length of the results, actually I call this output, pardon me. So if this length of the result, the output is not equal to the length of the integrity, I want to return elegantly an empty string. Otherwise, I can simply return the output as it is. All right, so this was definitely a good puzzle to solve. Let's actually see if my code runs, and I got an error. Okay. Actually, I had an indenting error because my while loop was inside my big for loop here, so I apologize for this. That was not intentional. So just if you follow along, you're gonna have to basically put all this last chunk outside of the for loop. So let's submit this again. And there you go. Great. So I hope you learned from this video. And I hope to see you in the next one.